Okay, we're on question number 8, and we had begun to talk about it. The first thing that we talked about was asymptotes. And we know that this is not a rational function like something over something, so the idea of asymptotes is less intriguing to us. We think about the square root, and if we thought about just a great basic graph of the square root, we would be thinking this. And so we know that you can't have the square root of the negative, and so there would be a whole region of the graph that would drop out if that was the case. But we don't just have that. Inside that square root, there's an x squared, and we have the idea that maybe that can have some cancellation, but it's a binomial in there, and then there's an x on the outside. So exactly what this thing's going to look like is a little bit maybe confusing to us at this time, but it's not rational. So the idea of having vertical asymptotes, horizontal asymptotes, and things is not realistic to us. But there could be a dead end place, so there could be some weird things happening because of the nature of all of those variables and radicals that are there. So we're going to talk about the limited domain as we have before. You cannot have the square root of a negative, and if the values of x were, if that was a negative 3, that would give us a square root of 0. If we had a positive 3, that would give us the square root of 0. So if we had something to the left of negative 3 or something to the right of positive 3, that would put a number in here that would create a number that's larger than 9, so you get a negative. So that says that my values of x must lie between positive and negative 3. So I have a limited domain because of the square root of the negative, and we'll need to think about that as we set up our intervals later. Okay, so at this point then we're going to find the x-intercept, y-intercept, and those things. So let's just begin, I believe we did in the other video, with the x-intercept, and then we'll go to the y-intercept. The x-intercept is the value of x when y is 0. So if we put a 0 for y in the function, we would have 0 is equal to x times square root of 9 minus x squared. We could get the junk off of the square root. Remember to solve a square root problem. Y'all remember the steps to that? You isolate the square root, you square both sides, and then you begin to solve. So that would be the thing we would do, is to isolate that square root. So we would take the x off, so we would divide by x. 0 divided x is 0, so we have 0 is equal to square root 9 minus x squared. Now that the square root is isolated, we will square both sides, and that will get rid of the radical, you see. So we're going to have 0 is equal to, the square cancels the square root, 9 minus x squared. Now we can solve by getting the junk off of x. So we're going to subtract 9. We would have negative 9 is equal to negative x squared. Divide by negative 1. We will have x squared is equal to 9. Get rid of the square with the square root. We would do plus or minus square root 9. And so we're going to have x is equal to 3 or x is equal to negative 3. So what we got there was a pair of x-intercepts. So we're going to have an x-intercept at negative 3, 0, and also 3, 0. Now, we notice that we did something. And you got to think about this when you get into calculus, and we start, and even in college algebra, college trig. We divided out an x here. If that x was 0, that would produce a 0 also, right? So we have to be careful when we divide off a factor to go back and think about the possibility of that factor producing a 0 in the numerator also. So when we solve that way, we still have to remember that x equals 0 is still a possible x-intercept. We could have then, instead of doing that, we may have more properly said we're going to set the first factor of x equal to 0, or set the second factor of square root 9 minus x squared equal to 0 and solve each one. And we wouldn't lose that x. If we just solved it down, you possibly lose an x. And sometimes when we're dividing by sine and cosine, that's where we're more likely to forget. We'll divide off a trig function and then forget that it was a product, so that could be equal to 0 also. Okay, so we have three x-intercepts. We're going to have an x-intercept at negative 3, 0, an x-intercept at 0, 0, and an x-intercept at 3, 0. Now, when we were thinking about that graph doing something like that just because of the square root, we realize now that this thing's doing something crazy because there's three x-intercepts. That thing's doing some wiggling if it's going to hit that x-axis 3 times. So we can already tell that this graph is not something that is a normal type graph that we would have seen before, you see. All right, so now we're going to look for the y-intercepts. The y-intercept then is the value of y when x is 0. So we put a 0 in for x in this original function. So we would have y equal 0 times square root of 9 minus 0 squared. And so we're going to have y is equal to 0. And so we have the ordered pair 0, 0. Which we would have known since we'd already seen that point right there. But we needed to validate there wasn't another one. And so if we think about, where else could that happen, there's no other place that could happen as we think about letting x be 0. So we've got three x-intercepts and one y-intercept. Any questions on that? And we want to remember that we have a domain limitation. So the graph actually ends and begins at one of those x-intercepts and it ends at the other because of the domain limitation, you see. So we have a limited graph that actually goes from the x-intercept of -3 to the other x-intercept of +3. Okay, now what we want to do is find our critical numbers and test points, and we want to look at the intervals. We want to determine increasing, decreasing, and then determine concavity. Think about relative maximums and minimums, and see if we can get a decent graph of this. Okay, so I'm just going to kind of clear the board there. I want to rewrite the things that were important to us. So I'm going to pause and just make it matter. Okay, so we found the domain, we found the x-intercept, we found the y-intercept. So I went ahead and rewrote the original function in exponential form because we want to now take the first derivative, find the critical number, second derivative, find the test points. So when we find the first derivative, f prime of x, it is a product and a chain. There's a product and a chain. So the product rule would say you take the first times, and the derivative of the second is going to be
1/2 parentheses 9
good. So exponent times the guts, and then reduce your exponent by 1. So 1/2 minus 1 whole, which is 2 halves. 1/2 minus 2 halves is -1/2. We're still doing the chain times the derivative of the guts, or the u part. So that would give us inside a -2x, right? So we have first times derivative of second, and then we would have a plus sign, and then we would have second times derivative of first, so we would have 9 minus x squared to the 1/2 times the derivative of the first, which would be 1. Now, we would like to factor out. We have a 9 minus x squared factor, and the lowest exponent is a half, and that's the only common factor. So we're going to have f prime of x is equal to, we're going to multiply everything that we didn't pull out.
We need Peyton Barber,
1/2 times
Derek Coley.
2.
Destiny Jones, please.
1/2 times -2 is -1 times x is negative 1x squared, so negative x squared. Whoops. We need to write that big part down first. So f prime of x, got distracted there with the announcement. I quit thinking for a second. We're going to pull out that common factor of 9 minus x squared to the negative 1/2. We're going to pull that out. And then we're going to take the leftovers from the first part, and we get negative x squared. Then we're going to have a plus sign, and then what will we get out of the second part?
9 minus x squared.
Remember, it'll be one of those, because we're thinking this times what is that? Well, you would add the exponents, and negative 1/2 plus 1 whole is equal to 1/2. So it'd be 9 minus x squared to the first, which is 9 minus x squared. There's nothing to distribute through that. Had this number been something besides 1, I'd say that had been a 2, we'd have had 2 times 9 minus x squared. And we would have had to distribute, but it's a 1, so it stays as is. Okay, now, we have then a situation where we can combine like terms. This is going to go to the bottom because of the negative. So we're going to have f prime of x is. In the numerator, we have negative 2x squared plus 9. And in the denominator, we have 9 minus x squared. The negative simply moved it to the bottom, and the half is the square root. So we have this situation for the first derivative. Okay? Any questions on that? Now, if we want to find the critical numbers for that, the critical numbers, we can let the numerator be equal to 0, right? Negative 2x squared plus 9 equals 0. That would be where the first derivative value is 0. Or we could set the denominator equal to 0. And that would be where the function value is undefined. Now, is there any value that you can plug in here and make that a 0?
3 or
So 3 or negative 3. So 3 or negative 3 would be critical numbers, right? And then what about here? Well, we would subtract 3.
9.
We'll have 9. Thank you. Negative 2x squared equal negative 9. Divide by negative 2. We have x squared is equal to 9 over 2. Take the square root. And remember, we did plus or minus. Now, remember we would split that, right, into square root 9 over square root 2, which would be 3 over square root 2. But we have to rationalize, so we multiply by square root 2. And remember, we had the plus or minus. We have plus or minus 3 square root 2 over 2. Plus or minus 3 square root 2 over 2. I'm going to wipe some out here so I can write my critical numbers. I want to save my first derivative there, which is right here. and then I'm gonna rewrite it. Okay, so my first derivative ended up being negative 2x squared plus 9 over square root 9 minus x squared. 9 minus x squared, I'll try to hyphenate the next one a little bit. So my critical numbers from least to greatest would be negative negative 3, negative 3 square root 2 over 2, positive 3 square root 2 over 2, and positive 3. So we have 4 critical numbers. Okay? And then we'll erase all of this. Okay, now we want to find the second derivative. To do that, we're going to rethink the first derivative as negative 2x squared plus 9 times 9 minus x squared raised to the negative 1/2. That way we can do it as a product rule rather than a quotient rule. There's going to be 2 chains involved anyway. So we have a chain, a multiplication, and a chain, right? And we want to do the derivative of that to get the second derivative. So we're going to have first negative 2x squared plus 9 times the derivative of the second, which is going to be, I want to put it in a bracket, right? Negative 1/2 of 9 minus x squared, subtract, which would give us negative 3 over 2, right? Raised to the negative 3 over 2 times the derivative of the inside, which would be negative 2x. So that's first times derivative of second. Probably should have written smaller. Now we're going to have plus the second. The second is the 9 minus x squared raised to the negative 1/2. Let me get that in there correct. I need to close my bracket on that first one. Bear with me and I'll get it in there. Let's go back and close our bracket on the first one. No, well, it's not time to close that bracket. We weren't supposed to close that bracket there. My bracket is that first thing multiplied by the 2 pieces, and I needed a bracket because inside there there's parentheses. Okay, web time to close the bracket. Okay, so we have plus second times the derivative of the first. Now, so we want the derivative of the first, which is going to be, if we have that exponent of 1, so it would be times one of those, negative 2x squared plus 9, and then we would have the 1 minus 1, which is 0. So that's going to be this raised to the 0 power and then times the derivative of the guts, which would be -4. And then we will close our bracket. I'm running through it to double check. See any mistakes? Let's double check. We pulled out. Oh, I forgot to pull out that term. We pulled out the -2x squared. No, I had. Stop. Okay, in the middle of that, I kind of got to thinking I was factoring out. I just kind of lost it there for a second, and I apologize. Let me go back through what we have. We are, and I made a couple of mistakes. I'm going to fix them. We were doing a chain rule, so we wanted first, that's this, times the derivative of the second, and that's what we're doing. To do that, we're going to take the exponent -1/2, that's here, then the guts, that's here, reduce the exponent by 1, that's the -3/2, times the derivative of the guts, that's the -2x, we got that. Okay, we're dealing with a product rule, so that's where the plus sign comes in. And then we need to do the second half, and so we're going to have second, that's the 9 minus x squared to the -1/2, times the derivative of the first. So on the derivative of the first, we've got this to the first, minus 1 is that to the 0. Now anything to the 0 power is 1, and I just went ahead and put that, but that's going to turn into a 1 right there, times the derivative of the guts. And the derivative of the guts is -4x. We left off an x. Now, what I don't need are those brackets. I didn't need these brackets. In my mind, I was factoring that out for some reason. I kind of lost what I was doing there for a second. I was thinking I may need to factor out later, and then I started thinking as if I was factoring out. Okay, so those brackets are not there. We didn't need them. Okay, now let's take the pieces that we have and let's try to put those together. Just kind of clean up just a little bit. So we're going to have f double prime of x is equal to -2x squared plus 9. And then when I multiply these things, I'm going to go ahead and do that. I'm going to have a -1/2 times a -2 is a positive 1 times x. So I have a times x, and then a times 9 minus x squared to the -3/2. And then I have my plus sign. Now this right here is actually equal to 1 because it was raised to the 0 power. So I'm going to have a plus, but then it's a times a -4, which is going to change that into a minus. So now that's a minus 4x times.
What about the minus 2x plus 9 minus x squared?
There's the plus sign, the second one. There we go. So minus 4x times 9 minus x squared to the -1/2. And again, that piece is a 1 because anything raised to the 0 power is 1. Okay, so we're good right there. We're good right there. I'm gonna pause the video and you can catch up on your own. Okay, so we're good here. I apologize for inserting those brackets. I got in my mind we were factoring out. Now we do need to factor out. Okay, so we need to look for common factors. Well, there's no common numerical factor like that 4 doesn't have a partner over here, but this x does. So there's a common x we can factor out. This 2x squared plus 9 doesn't have a common factor base over here, but the 9 minus x squared does, and the lowest exponent is the -3/2 one. So we're going to factor out an x times 9 minus x squared to the -3/2. Okay, so we're going to have f double prime of x is x times 9 minus x squared raised to the negative 3 over 2. Now I need a parenthesis or a bracket or something because I'm pulling this factor off. Okay? And what I'm going to have left to start with is this piece, which is a negative 2x squared plus 9. And there's a minus sign after it, and so I'm not needing to put it in parentheses so I can distribute something on it, okay? And then on the other one, I've got a negative 4, and then when we think about how that always happens, to go from this exponent to that exponent, you would have to add 1, which is like adding 2 over 2 to negative 3 over 2, you get negative 1 over 2. So we're going to have negative 4 times one of those. So we're going to have to write that in parentheses, 9 minus x squared, understood in the first power, and then we can close that parenthesis. And that's where, instead of a double parenthesis, you could have put a bracket there, okay? That's where my bracket was coming in a while ago. I was getting ahead of myself. Okay, so we need to distribute here. We're going to do maybe a couple of things at once. This x is going to stay on top. This negative is going to throw this stuff to the bottom. And then we'll try to simplify in here, which is going to go on the top, and we'll see kind of where we're at. So we're going to have f double prime of x is, the x is on the top, the 9 minus x squared goes to the bottom. It's raised to the 3/2. The 3 is a power of 3, and the half is a square root. So we have square root of 9 minus x squared to the third. Basically, we got that 3 over 2 taken care of in the negative. Now, in the numerator, this is going to be a negative 36 plus x squared distributed. We have negative 2x squares and positive 1x squares is a negative 1x squared. My smartphone office is going to be tough. So we got a negative 2x squared, a positive, that's a 4. I lost my 4, didn't I? A positive 4x squared, positive 4, negative 2, positive 2x squared. Negative 4 times positive 9 is negative 36. And I'm going to pause and let you catch up. And so we have that negative 36. We also have that plus 9 we forgot to see. So that's going to give us a positive 9, and a negative 36 is a negative 27. So that's going to be a minus 27 there. Thank you. And I think we've got all the pieces. It's always good to stop and take a look and make sure you're right, and then go ahead, right? And this x was factored out on top, so it's an x times on top right here. That's multiplication. And this is what we pulled out of those parentheses, so we need a parenthesis right here. X times 2x squared minus 27. It's good to triple check also. It's so easy to make a mistake. You get caught up in all these things. So really, you should take your time, go back through it, double check everything that you did. Okay, so we pulled out a factor of x, that's an x times on top. We pulled out this factor, but the negative is going to put that part on the bottom. So there's that x multiplied on top. There's that 9 minus x squared to the third that went to the bottom. There's your square root part, and there's your cube part, and there's the throw it to the bottom part. This was a times the result, and so we put the result in that parenthesis. We could distribute that, or we can just leave it factored. Now, obviously, we would want to leave it factored because we need to find the test points, right? And that's about as simple as we're going to get it. And so we'll leave the second derivative like that, and then we'll search for the test points. for the second derivative. So let me clean out some board space. I'll just cut it over there. We want to be able to write our second derivative answer. I'm just going to cut into that so we can keep our work going in a decent way. So my second derivative in a somewhat decent looking form turned out to be x times 2x squared minus 27 over square root of 9 minus x squared cubed. Okay, and I'm going to remove that from the bottom so we can continue our work, trying to stay as organized as we can with the board that we have to deal with here. Okay, so the test points, if we want to find the test points, that's where the second derivative is equal to 0, are undefined, so we can set the numerator of x times 2x squared minus 27 equal to 0. And we could set the denominator of square root of 9 minus x squared cubed equal to 0. Or we could think about where what in the square root, right? What inside that square root can't be negative, so we would have to kind of think about 9 minus x squared cubed has to be greater than or equal to 0, right? Which again would produce some domain limitation. When you think about that, the values of x that would make that happen, for that to end up being a negative, we're going to be cubing something. If this turned into a negative number, right, and we cubed it, it would still be a negative number. So this cannot turn into a negative number. For that to be a 0, it would have to go from negative 3, positive 3. If that number was like a negative 4 squared, it'd be 16, we'd get a negative. So what we're finding is the limitation that we're finding in the second derivative is the same limitation we had in the original domain. Are you seeing that? Okay, so if we observe that. Now, we want to set this equal to 0, so either x equals 0 or 2x squared minus 27 is 0. And so we could add 27. We're going to have 2x squared equal 27 divided by 2. We're going to have x squared is equal to 27 over 2. We're going to take the square root and do plus or minus. The 27 divided by 3 is 9, divided by 3 is 3. You have a pair of 3s, so out pops a 3, and you have 3 square root 3. If you do the prime factorization part of that, this was like square root 27 over square root 2. So what we have now is x is equal to plus or minus 3 square root 3 over square root 2. The square root of 27 turns into 3 square root 2, 3 square root 3, and then you've got the square root 2 on the bottom. And then you would need to rationalize, so you would multiply top and bottom by square root 2, and you're going to have 3 square root 6 over 2, plus or minus. So plus or minus 3 square root 6 over 2. Okay? Now, just punch that in the calculator. Punch in 3 square root 6 over 2. See what you get. That's like, well, now we have all these nasty stuff. We got this negative 3 square root 2 over 2. We got 3 square root 2 over 2. We got positive 3 squared 6 over 2, negative 3 squared 6 over 2. But what's that number?
3.67.
Now that was really handy because that's out of the interval, which was handy. So we don't have to mess with those because they're not in the interval. Well, that was handy. So test points, none in the domain. No test numbers landed within the domain. At least those didn't, right? This one did. This x equals 0. So none in the domain except x equals 0, which gives us that test point. If we think about what would produce a 0 over here, these two got kicked out. We still have to solve this side, and I apologize for that. We would need to square both sides. And so we're going to have 9 minus x squared cubed is equal to 0. And then we're going to cube root to get rid of cube. We're going to have 9 minus x squared equals 0. And then we're going to subtract 9, subtract 9. I'm going to have to clean house a little bit. Now I'm going to have to say none except this and this and this. The deal is those 3 squared 6 over 2's were not in there, but we're going to have 3 that are, right? Okay, so we're going to have negative x squared is equal to negative 9. Divide by negative 1. We're going to have x squared equal 9. We're going to take the square root. We're going to have plus or minus square root 9. We're going to get x equal 3 over negative 3. Okay, so we probably don't need to say none in the domain except. Those square root 6 things were not in the domain, but there's 3 things that are in the domain. They are negative 3, 0, and positive 3. 2 of those were actually critical numbers. So we found our domain, we found our x-intercepts, we realized there's no asymptotes to talk about. We found the y-intercept, we found the first derivative and the critical numbers of negative 3, negative 3 squared 2 over 2, positive 3 squared 2 over 2, and positive 3. We found the second derivative, and then we found the test points. We actually had 5 test points, but 2 of the 5 weren't within the domain limitation, so we cast those out, and we're left with the 3 test points of negative 3, 0, 3. Remember, critical numbers, we use those to set up intervals to help us find increasing and decreasing. The test points, we set up intervals to help us find concave and convex and points of reflection. And so we will, next time, in the last video in this section, we will set up our intervals and we will build our chart, and then we'll put all that together in graph. Any questions so far? Apologize for the 1 or 2 little blunders. That's easy to do with this much calculation, so it is a good lesson in stop regularly, double check, triple check before you move forward, because you really don't want to finish this with one little mistake at the front and have to start over. All right, appreciate it.